Hi everyone, welcome to another video in this system design series. In this video, we would be talking about forward and reverse proxy. So let's get started. So first of all, forward proxy is nothing but a machine which sits between the client and the internet. Okay. Similarly, reverse proxy is also a machine, but this machine sits between the internet and your backend server. Okay. So one difference between forward and reverse proxy is the placement, right? Forward proxy sits between the client and the internet. Reverse proxy sits between the internet and the server. Okay, that's the first difference. Now, in order to understand the difference in depth, let's try to understand the use cases of both the proxies. Okay. Now let's try to understand the use cases of forward proxy. So forward proxy is majorly used for three purposes: security, access control, and caching. So let's understand this three purpose with the help of one classic example of colleges and students. So assume that these are the students who are currently studying in a specific college, right? And that particular college has already configured a forward proxy. That is, if any student connects to the college network and tries to visit a particular website on the internet, in that case, that student's request will first go to the forward proxy. Why? Because college has already configured forward proxy. Okay. So the request of student will first go to the forward proxy, and this particular forward proxy is going to initiate a new request to the server on the internet, right? So assume that this user or this student wants to visit facebook.com, right? And he's already connected to the college network. So the request will first go to the forward proxy. Forward proxy is going to establish a new connection with the server of facebook.com. Let's say this is where facebook.com is deployed. So one new connection will be established to the server, right? So this server is going to think that the real client is this machine, but in reality, the real client who initiated the request was this, right? So this is how forward proxy hides the details of the client. Okay, that's the first point. The second point is access control, or second use case is access control. In access control, the first thing is restriction. So generally, colleges configure forward proxy because they don't want their students to visit any random website. They only want their students to only use educational websites, right? So if at all this particular student tries to visit facebook.com, his request will first go to the forward proxy. And since college has not whitelisted facebook.com, that particular request will be blocked. All right. So that's the first thing, restriction. So the second thing is bypassing. So in order to understand this point, let's take another example. So let's say these are Indians, right? And they want to visit TikTok social media application, right? But the thing is, they can't do that directly because India has banned TikTok.com. Okay. So if at all any Indian wants to use TikTok.com, in that case, what they can do is they will first connect to a VPN server which is outside India, right? So assume that that particular server is present in USA, right? So when this particular user connects to the VPN server, in that case, his request will first go to the VPN server, and that VPN server is going to establish a new connection to the TikTok's server, right? So that VPN server is acting as a forward proxy. It is allowing this particular Indian user to access TikTok.com, right? So that's the second use case. The third use case is caching. So let's go to the first example again. So these are the students and they are currently studying in a specific college. So assume that all of them are studying Java, right? So obviously they would be visiting Java's official website for learning, right? They would be checking out the documentation of Java. So what college can do is they can cache the documents of Java over here, they can cache the HTML over here. So next time, if any student tries to read any particular documentation of Java, their request will first go to the forward proxy, but this forward proxy will not establish a new connection to the Java's server. Instead, it will directly return this particular HTML page which has been cached, right? So this is how we can save the bandwidth and reduce the latency as well, right? So these are the three major use cases of forward proxy. I hope you got this use cases. Now let's try to understand the use cases of reverse proxy. So the very first use case of reverse proxy is security. So over here, reverse proxy is going to provide the security, but this time that security will be provided to the server, right? Earlier it was provided to client, but this time it is provided to server, right? The clients who are present on internet, they can only see reverse proxy. That's it. They do not know whether behind the reverse proxy you have one server, 100 server, and whatnot, right? All the IP address of the servers are hidden from the clients on the internet. Okay, so this is how reverse proxy hides the details of the servers from the clients. Okay, the second use case is caching. I think this is understandable. We can cache the static content or responses of APIs over here itself in the reverse proxy, so that next time if any user wants to fetch that particular static content or calls the same API again, the response is directly provided by the reverse proxy. Okay, so this is how we can reduce the latency. Point to note over here is you should only cache those stuff which are static or which do not change frequently, right? For example, products do not change frequently, right? So you can cache products for 10 minutes. Okay, that's a second use case. The third use case is load balancing. So as you can see, we have 3 servers. So if at all any request comes from the client to the reverse proxy can distribute that request to one of the server, right? It can use any algorithm for distributing the request. Okay, so that's the third use case. Then the fourth use case is routing. So what you can do is you can basically route a request based on the host or based on the path. So if let's say this is where your payment service is hosted and this is where your booking service is hosted, right? So what you can do is whenever a request comes to this reverse proxy will check the path. If the path has /checkout, in that case it will forward that request to this server. If the path has /book, in that case it will forward that particular request to this server. So based on the path or based on the host, you can route the traffic. Okay, you can, as in reverse proxy can route the traffic, right? So this is the fourth use case. The fifth use case, you can perform rate limiting at reverse proxy itself, right? So whenever a request comes from the user, here itself you can rate limit that particular request, right? You don't even allow that request to reach the backend server. Okay, so this is the fifth use case. So the last use case is SSL termination. So the thing is, the clients only trust your website if your website is secured, right? If your website does not have HTTPS, in that case, the clients will not visit your website, right? So if you are aware about HTTPS, then you might be knowing that we need to terminate that particular connection, secured connection. So in order to do that, we need SSL certificate. Okay, so if we don't use SSL certificate at this level, in that case we need to use SSL certificate in all the servers. So if you have 50 servers, then you need to install the SSL certificate in all those 50 servers. So managing SSL certificate becomes hard, right? Because you need to renew those certificates again and again after they are expired. Okay, so what generally we can do is, instead of having SSL certificate on all the servers, we can have that certificate over here itself. So the secured connection is between the client and the reverse proxy. Okay, so there is HTTPS between these two. right? But from reverse proxy to your server, you can directly use HTTP. That's it. Because here itself, you are terminating the SSL, terminating the secured connection. Got it? So this is the sixth use case. And I think many people get confused between load balancer, API gateway, CDN, and reverse proxy. So the thing is, load balancer, API gateway, CDN, all these three are basically a reverse proxy. Okay. All of them can do this stuff, right? All of them can do this stuff. But the thing is, they have some specialization. See, you are also engineer. I am also engineer. I am specialized in something. You are specialized in something else. Similarly, all of these three things are reverse proxy. But load balancer is specialized in traffic distribution. API gateway is specialized in API management, right? Routing, rate limiting, authentication, authorization, etc. CDN is specialized in caching. So I hope now you are getting the difference between these components. Okay. So I hope this video was useful for you. If it was, then please like the video and share this video with your friends. Thanks for watching.